Okay, thanks everybody. We are going to get started on tonight's webinar on building the business case for 60 gigahertz fixed wireless solutions. The webinar is being recorded and you will be able to view it on YouTube and also on our community at community.cambiumnetworks.com. During the course of the presentation, if you do have any questions that you would like to ask any of our presenters, please use the question and answer dialog box on the right-hand side of your screen. Also, we have the data sheets for the products. Those are available also under the handouts button on the right-hand side of your screen as well. So our guest speakers tonight, first off, we are honored to have with us Mr. Praveen Sampath from Facebook Connectivity. He's one of the product managers there. And also Sagar Deshpande, who is from Cambium Networks. He is our product manager for the 60 gigahertz solution. I'm Ray Savage in the marketing group. And again, if you do have any questions during the course of the presentation, please post them using the question and answer dialog box. And so without any further ado, I'd like to get started.
Thank you, Ray, for the introduction. And this is Praveen Sampath here from Facebook Connectivity. Thank you all for joining us. So we are very excited to be introducing Cambium's new products based on Telegraph technology. And we are also very excited about the prospect of Telegraph addressing one of the biggest focus for Facebook Connectivity, which is fixed broadband to households and businesses. We believe that Telegraph as a technology has the opportunity to address a market of about 500 million subscriptions over the next 5 years. And we are looking at this market in two fundamental ways. One is high penetration, which is basically countries that are in North America, in Europe, in Northeast Asia, Australia, New Zealand. In these markets, there's very high fixed penetration, usually north of 85%. And so anyone who has a business or a home usually has a existing broadband connection to it. But most of the time, those are being served by copper infrastructure for last mile. This could be DSL coming to someone's home or through the cable provider. Some of the fundamental limitations with those technologies is the speed and symmetric service. It's really hard for a DSL service provider to offer 100 megabits per second or higher as a quality of service. And it's also hard for a cable provider to give symmetric service to a business which desperately needs it for its employees. So we fundamentally see a technology like Telegraph could be an ideal fit for this particular market where service providers are looking for cheaper options to provide fiber-like experience for their customers. And Telegraph could be one of the underlying technologies that could help them deliver that along with the help of Cambium's CNWave products. The other part is the lower penetration markets, which is predominantly what you see in regions such as Latin America, where it could be in the 20 to 30% range, and in countries that are in Africa and Southeast Asia, where it's usually less than 10% in terms of penetration, fixed penetration. Here, these are mobile countries, mobile-first countries, so we have a big, a subscription base of mobile subscribers, and even though there is a clear need for a fixed solution at home, the cost is too high for them to be able to afford it. So with the help of the innovation that Telegraph is bringing in and with products such as CNWave, we're fundamentally hoping that we will be able to add new fixed subscribers to come online in the next 5 years using Telegraph technology. And not just that, there are also high ARPU customers, typically businesses and smaller mid-sized enterprises who are ready to pay $20, $30, $40 a month for a good broadband connection, but have fundamentally very few options to pick from, and which are limiting in terms of what they experience. So we see Telegraph addressing that particular segment of users as well. And also the residential customers who are currently limited to typically something less than 50 megabits per second, and Telegraph technology could be the underlying one that could enable them to reach to the next tier of service. So yeah, very excited to bring this technology to you guys, and I will turn to Sagar now to talk about CNWave Cambium products.
Thanks, Praveen. Next slide, please. Yeah, so this is our CNWave solution. We have 3 products, the V5000, V1000, and V3000. The V5000 is the distribution node. It's similar to the access point, but the DN or the distribution node can talk to other DNs as well along with the subscribers. We have two subscribers, the V1000 and V3000. The V1000 is the mid-gain client node and the V3000 is the high-gain client node. So all the products, the V5000, V1000, V3000 are Telegraph certified and they do support mesh. They're based on the 802.11 AY standard, and they will support channel bonding. So they are hardware capable, and once the software is ready, it will be upgraded to a channel bonding feature. So with channel bonding enabled, the performance for the V5000 is about 15.0 Gbps overall. And in installation wise, all the products support bidirectional with auto beaming forming supported. It also has auto healing mesh. The radius could be configured in a traditional point-to-point or point-to-multipoint, or it could be controlled in a mesh format as well. We will touch upon mesh in a few slides later on. All the products, not only the CNWave products, all the existing Cambium products supports a CN master or a single plane of class, and the CNWave products will also be supported over there. So it will be easier to manage the entire network portfolio. Yeah, talking a little bit more details on the V5000. So the V5000 is a 280-degree coverage radio. It has two sectors, sector 1 and sector 2. So each sector is about 140-degree coverage. The radio supports channel 1 to channel 4, which means it supports from 57 to 66 gigahertz. The modulation it supports is up to 16 QAM with ACM, automatic channel modulation, which means it's a seamless transition between any levels of modulation. The throughput that it supports is 1.9 Gbps uplink and 1.9 Gbps downlink per sector. So if you have to multiply that by 2 if you want to take the coverage of the entire V5000. And of course, once you have channel bonding enabled, this number doubles. Basically, channel bonding is a feature where you combine adjacent channels to provide double the capacity. As I mentioned, the V5000 is dual sector with 280-degree coverage, and they do support beamforming. This beamforming is really essential, especially to avoid and mitigate interference from other radios, and it also helps in aligning and finding the best possible path to the subscribers. With respect to configuration, the V5000 can support up to 30 subscribers, out of which 4 subscribers could be DNs and the remaining 26 could be CNs. So any combination in between, we do support that. The V5000 has a very low latency. This is one of the key advantages. The latency per hop is less than 1 millisecond. Next slide, please. Yeah, so this is an example deployment of a suburban area, residential suburban area where we are providing wireless to homes. The green line represents the DN to DN connection. As you can see, it forms like multiple mesh rings. So in case there is a link failure or there is some sort of low interference, or due to high interference, there's a low signal RSSI strength, the path automatically reroutes to a better option. And that way you always have connectivity, or you always have the best possible connectivity given the environmental circumstances. So the DN to DN, they form a mesh, and the DN to CN is the last mile to the homes. As in this example, we have connected a few homes, and each of those homes will have probably a Wi-Fi inside the home to provide Wi-Fi connectivity for that space. So this kind of gives you like a high level example of a deployment in like a normal suburban area. Next slide. So, okay, so this is another deployment scenario where this is near a lake shore. It could be near a river side as well, where you want to connect building to building or rooftop to rooftop. And you also have a point to multi-point connectivity a little bit on the edges. It's if you're going with the traditional route of either digging trenches, it's very difficult, especially if you're close to the river, given the conditions, environmental hazard and regulatory approvals required. So rooftop to rooftop on these might be a really good option and to provide a high capacity solution. We will be also covering in the next few slides like a real case study and for deployment which compares the two as well. Next slide.
Okay, it's time for our first poll question. This is part of the interactive part where you share your ideas. And our first question is, what do you find the most significant challenge to deploying 60 gigahertz? What's the biggest obstacle? Is it funding and financing? acquiring and managing site leases for equipment, availability of equipment, specific technical expertise on installation and operation, or is it something else? It's very easy. All you have to do is just point and click whichever one of these things is the most significant challenge. And we will be able to leave this open for about 2 minutes or so, and then we'll be able to share the results right away. Okay, and let's close that one out. And how do the results look? Okay, very interesting. In the lead is the difficulty in acquiring and managing site leases for equipment, to locate that equipment. That's a very interesting response there. And then I've never seen this before. We have a four-way tie for funding and financing, availability of equipment, technical expertise, or something else. So obviously, boy, you look at that, that's 3 times the number of people say that acquiring and managing site leases is the most difficult thing. Thanks very much. That's very insightful. And don't forget, if you have questions about anything, just use the question and answer dialog box on the right-hand side of your screen. So let's start taking a look at the planning.
Sure. Thanks, Ray, and thank you, audience, for the votes. It was very insightful. And so, looking at the next set of slides, we'll talk about how one would go about planning deployment with Telegraph as the underlying technology or CNWave products. So we have broken it down into 3 stages. The first stage being a service provider doing a site survey and planning in the area of interest where they would like to deploy a fixed wireless access using CNWave products. So the first thing is the square kilometers to be covered and the number of buildings that need to be connected. And the second would be the number of potential subscribers that could be connected to this network, and the take-up rate assumptions on how much percentage of the addressable number of subs will be converting to CNWave product users month over month. And also the different quality of service tiers, as in how many users would be 100 megabits, how many would be 200 megabits, how many would be 500 megabits, because that all goes into the capacity calculation needed. The result of that will determine how many points of presence, this are fiber points of presence or microwave points of presence, that are needed in order to deploy a mesh network using CNWave, right? And also the main thing is, in a given site, a service provider could have multiple options to choose from, right? Like it could be either street pole or rooftop, or a hybrid, as in it could be a combination of street pole and rooftop. So all these are essential inputs that go into determining the network plan for the given site. The second level then is the distribution node configuration. Again, if you're not familiar with Telegraph terminology, distribution nodes are the ones that distribute capacity through the network. So some of them are connected to points of presence, and a lot of them are not. And together they create the mesh network and distribute the fiber capacity across the area of interest. So the first thing there is to identify the site locations where these DN nodes will be mounted. Again, it could be rooftop or pole top mount. Then using those DN sites, the network planner then comes up with a line of sight identification and optimization to create the mesh, and also to create the DN to CN connection, and the CN being the node that goes into a certain subscriber's home or outside the home, on or outside the home, or business. And then it's the installation and the provisioning of the DNs. So, and then with these, we calculate the TCO or the CapEx for home pass. And the third layer, or the third step here, is the consumer installation. So now you identify the site, you identified all the DN sites that need to be located, need to be installed. You've connected those DN sites, right? And you created the whole mesh network to pass the entire neighborhood. This last step is to connect the consumer to that particular network, right? So the kind of decisions there are, where should the CN be placed? As in, is it on a per subscriber base, as in every subscriber unit will get their own CN, or will it be a shared CN in a given building? what will be the cost of installation, and that'll be dependent on rooftop or building side mount. How do I connect the consumer's premise to the CN, right? Is it power over Ethernet? Where do I place a Wi-Fi router? How do I provision it? Things like that. And together, these elements constitute the CapEx for home connected. So in the next few slides, Sagar will be walking you through these steps for a given area of interest using the CNWave products. Sagar, please go
Thanks,
ahead.
Praveen. Thanks, Praveen. So this is a design example and challenge that we will be taking up. So this is a suburban deployment in Northeast, I think in Alaska. We have about 300 homes that need coverage, but we want our solution or design challenges, we want to provide 100% coverage and offer the customers from 100 Mbps to 250 Mbps capacity. And we have an assumption of about 40% take rate. And the solution we're going to provide is using CNWave and AMP tool. We're trying to provide 100% coverage with a deployment style which includes PMP with mesh, kind of a combination and configuration. Right. Next slide. Yeah, so using the AMP tool, which is designed by Facebook, it uses LiDAR data, and we have to place in like the points or where you want the lampposts are, or where you want to deploy it on top of rooftops. It is possible to create all the line of sights that the AMP tool generates. So this is like the subset. So this is the combination of all the possible links that are available from the POP site all the way to each subscriber. And based on parameters such as your pop capacity, number of hops, capex, subscription rate, budget or line of sight, or maximum distance for line of sight, or specific MCSs that you're trying to hit, all of these links compress into like specific links that can be used to provide a specific deployment example. So the AMP tool uses LiDAR data, and it uses all the parameters provide as I mentioned, and it generates a final outcome. And the outcome is next slide, please. Yeah, so this is the final outcome based on the specific parameters that we have given. So if we were to change any of the, for example, subscription rate or max pop site, the configuration would have been slightly different to accommodate those needs. So in this case, we can clearly see like the pop site is somewhere in the top right side of the corner, and from there you're getting the capacity spread out across multiple DNs. I think in this case is about 18 or 19 DNs, and which connect to all the 306 homes as well. So some homes could be mounted with DNs, and majority of them would be mounted with CNs as well. As part of the AMP tool, if you click on any one of the nodes, we will see a clear definition of what the height of the DN is supposed to be, what angle, what inclination, what RSSI is it supposed to expect, what kind of throughput you're going to expect, and then you can play around with this tool on your own. So it's a really nice planning tool that we have to deploy or use for a large scale kind of deployment. We also have a tool called Link Planner, but that's primarily for point to point, point to multi-point, but it doesn't include like the mesh capability that the AMP tool has as of today. So if we are planning for like a specific district or like a township or some sort of historical site where you cannot lay fiber, this would be a really good example of how you can utilize the tool well. Next slide. Back to you, Ray.
Okay, thanks, Sagar. We now have our second poll question, and this one is taking a look at deployment and deployment styles. So as you consider your primary architecture, where you're going to deploy 60 gigahertz first, what is your primary architecture to deploy a fixed wireless 60 gigahertz distribution network? Are you looking at rooftop to rooftop multi-point, rooftop to rooftop point to point, street poles in an urban area, or something else? So again, what we're looking for is where are you going to start with your 60 gigahertz deployment? All right, let's see how we did. Okay. Wow. All right. So rooftop to rooftop multi-point is exactly half of the respondents. Coming in second is street poles in an urban area. And then rooftop to rooftop point to point is about 13%. So it looks like it looks like we're going mostly for urban areas, and that's exactly what 60 gigahertz is designed to serve. So thank you very much. And don't forget, if you have any questions during the course of the presentation, just use the question and answer dialog box on the right-hand side of the screen. Okay, Sagar, I think we come back to you a little bit.
Yes, thanks, Ray. So based on the previous suburban deployment or sample deploy or design deployment that we did, we came up with two comparisons, total cost of ownership. On the left-hand side, on one side, we have the fiber of FTTH fiber to the home, and on the other side, we have the CNWave. So we broke it down into two sections. One is the home pass breakdown, which means what is the cost of a technology to bring it to the front of your doorstep, and what is the cost of the technology to bring it from the front of your doorstep inside your home, right? So to break it down that way. So if we start with the fiber to the home, typically they use like enclosures, cabinets, cables, and trenching. Those are the four main primary costs, and based on the distances that we measured for those specific for that specific suburban area, it came down to about $200,000. And since there are 306 homes, so if I divide them equally, it would be about $658 on average. Whereas if we have the CNWave home pass breakdown, we have the POP installation, we have the DN. I think the DN was about 17 to 18 DNs that needed some installation. So you can clearly see, so the total cost of deploying those was about $82,700. So if you divide that by 306, it's $270 on average. So it's a very, so getting the fiber, getting the CNWave to the doorstep is significantly cheaper with respect to fiber, which kind of makes sense. Right. So the next part is the connection to the home. So if you want to bring fiber into your home using the ONT, the optical network terminal, which is where it terminates for all the 306 homes, and which includes termination and installation, it costs around $91,800. So if you divide that by 306, it's about $300 each. Whereas CNWave products, if you have the CNWave installation, CNWave cost of the rate DNs as well as the installation cost, it comes down to about 125,000. So divide that by 306, it's about a little over $400, right? So you can clearly see that. Sorry, next slide, please. So if you add up the breakdowns as part of the total cost of ownership, it clearly makes sense that CNWave products provide 41% advantage over fiber deployments for this specific scenario. So I think overall, it's much, the key advantage or the key takeaway from this example is getting fiber to your doorstep is extremely cost effective, especially if you have like city centers where this cost could be astronomical because of the permits or the type of fiber you have to inlay. And the example that we used here was just like a suburban area, but if you go to a urban area, maybe you cannot cross a specific street, so you have to go around. So the cost of getting fiber to the doorstep is going to be much higher. So this kind of illustrates that basic point.
Well, yeah, just Sagar would like to add one more comment here. As Sagar was mentioning, the example we took for this business case was a fully connected suburban neighborhood where all 306 homes need to be connected and also passed. We understand that that might not be typically what a service provider has in mind when they go to a new neighborhood. Sometimes it might be just about addressing select few homes or select few businesses in that community, not connect the entire area of interest. And for that, what we would see is an even bigger saving in terms of cost per home passed. It'll be much higher than the 41% that you see here. It'll be a lot more of savings because you can selectively target the businesses and the homes that you want to go after rather than building a network that passes the entire neighborhood. So that's another unique advantage of Telegraph, which something like FTTH does not really have, because you can pick and choose and be opportunistic about your deployment and specifically targets the one you want to connect at a very, very low lift from the initial CapEx standpoint. Go ahead, Sagar. I just want to make
Great. That's a great point, Praveen. I think also when you start to take a look at it, obviously this is a generic example solution that we have here. It would be right for any network operator to say, well, I'd like to understand what it is in my particular case or in this particular example. Please contact us at Cambium Networks, and we will be more than glad to work with you on using these exact same tools that you see here on your specific exact challenge area that you'd like to connect. Okay, let's go to the next slide, Olivia. And I guess in summary, as you start to take a look at your deployment, there's a lot more that goes into it than just the radios and just the planning. The Cambium Network Solutions provide multi-gigabit wireless connectivity. So in addition to the 60 gigahertz distribution network, we also have Wi-Fi 6 wireless access points. And we also have backhauls for long-range point-to-point connections, and also licensed and unlicensed backhaul network infrastructure. We have a low total cost of ownership, as Sagar pointed out. We have a 280-degree coverage area on the V5000 DN. So that simplifies the installation where there's no need for a site router. We also have the V1000 and the V3000 CNs, client nodes, that can be designed into your network to meet the specific applications. We have the easy planning software, just as you saw, the advanced network planner, and also our link planner solution, so that you can efficiently design the networks. And our radios are equipped with automatic beamforming, so that they can actually complete the installation on their own. And as Sagar pointed out, we have channel bonding, which in effect, in many cases, doubles the throughput of the network. The other great thing about Cambium Network Solutions is that we have our CN Maestro cloud-based management system that gives you a single dashboard view of the entire wireless network, whether it's the 60 gigahertz distribution network that we've focused on here, the Wi-Fi access points that are used with that network, or the wireless backhauls for point-to-point connectivity getting to an area. All of those are controlled and managed through one pane of glass with our CN Maestro system. So with that, one thing I'd like to do, just go to the next slide. If you do have any questions or comments, please add them to the dialog box on the right-hand side of your screen. Or if you want to just contact us to get a consultant to speak with you and model your network, your connectivity challenge at no charge, we will be able to do that. You can just reach out to us at cambiumnetworks.com/contact us, and we will get in touch with you and walk you through using some of these tools. Praveen, we did have one question, and that was, can somebody download these tools and do this themselves?
Yeah, Sagar, do you want to take that? Yeah, are you talking about the advanced network planning tool?
Yes.
Yes.
Yeah, Sagar, please go ahead. Yeah.
Yes, thanks, Praveen. So the advanced network planning tool is only available for Cambium networks. The reason being, we have to this AMP tool takes in LiDAR data as a primary data. The primary data also needs subsequent attachments, which has to be generated by a special software. And it requires some specific expertise to generate those files. So that's why we are happy to work with any end customer, distributor, or any opportunity to help create and maintain the AMP tool and for further analysis. So if you have like a tool and you feel like, okay, we have to make slight modifications or adjustments, it's easier to work with the experts rather than figuring it out by yourself. So we welcome everyone to come and talk to us about the opportunity, and we'll be able to help out with the MP tool.
Great, thank you. We also had this one come in. Will the DNs fail over to another DN if their initial connection is lost?
That's a good question. So the answer is yes. It has to be built. The E2E controller or the CNWave mesh model needs to have failover links already built or predicted or added to the network. So in case one of the links fails, it's going to latch on to the other DN that is available. Also, the meshing capability enables or multiplies this factor by a lot. So for example, it's not just link lost. It could be like, hey, my specific link is losing MCS due to any specific, like maybe there's an obstruction or something like that. Maybe it goes down from MCS 12 to maybe MCS 3. And that way, that will also trigger a meshing algorithm to kick in and give a better optimized path to reach to the subscriber. So it's almost a lot of intelligence has been built into it.
Great. Taking a look at the client nodes, now we have two of those, the V1000 and the V3000. This question was, are there any plans for a reflector for the V1000 low-cost client node?
No, as of now, we do not have a low-cost client node plan in design, but maybe in the future we will definitely consider it.
Great. This one also, Sagar, I think is for you. Here's somebody that's already familiar with our link planner software. Can we just use link planner to predict the performance of CNWave equipment?
The short answer is it depends. So of course you can plan links using link planner, point to multi-point kind of thing. But if you start to add to scale, people who have used link planner already know this. But if you want to plan hundreds of links in a small neighborhood and take into account all the interoperability, it makes sense to use the AMP tool. The other advantage of AMP tool is it accounts the meshing component into the system itself. Whereas if you just want a traditional point to multi-point kind of a fixed wireless solution, link planner might be a good option. Also, there's another added advantage/disadvantage for link planner uses Google Earth LiDAR data. So it's very good to generate like a rough estimate based on 10-meter data LiDAR data, whereas the AMP tool we use typically uses 1-meter LiDAR data to maybe 1 feet. So the course or the fineness of the results is much higher. So if using the link planner, you may see a line of sight, but if you see a line of sight in AMP tool, it's a guarantee that it's going to be a line of sight in deployment. Whereas the line of sight in link planner may have some irregularities because the LiDAR data uses 10-meter data.
Great, and obviously if you want to find out more about any of our equipment, please visit our website. There's a lot of information about the CNWave equipment there. There's also a lot of good solution papers about using millimeter wave technology. And certainly you can discuss any of the issues with network operators around the world on our community. You can get there by going to community.cambiumnetworks.com. And looks like we do have one more question that popped in. Sagar, can you tell us when these will be available for shipment? Okay, looks like Sagar's on mute or something. The equipment will be available for oh, go ahead.
Yeah, sorry, I was on mute. Sorry, my bad. Yeah, the radios will be available by end of October for general availability. You can contact your RSM or regional sales manager or technical manager or the distributors for more information.
Great. Well, thanks everybody. Thank you very much, Praveen. It's been a pleasure working with you, and Sagar, thank you. Thanks everybody for joining us. We look forward to seeing you on the community and working with you. And if you have any questions at all, please, as it says on the website, go to cambiumnetworks.com/contact us. Thanks and have a good day.
Thank you, Ray.
Thank you.
Thank you.
Thanks.
Thanks, everyone.